Hey guys, this is Swati Sneha from Bigdataonlineschool. In this video, I'm going to cover some of the important concepts used in Sparc, like lineage concept, lazy evaluation concept, partitions, Sparc APIs, and some other thing as well. Also, I'm going to cover Sparc architecture in detail in this video too. So please be with me till the end. Let's start with the important concept called lineage. As you know that for lineage concept, it's like you are going to the transformations, but it will not execute until and unless actions are called, right? It's like when you call a transformation, Spark doesn't execute it immediately. Instead, it creates a lineage. As you can see from this picture, like the first RDD we have named as RDD, where I'm going to read a file called spam.txt. Here in this RDD, this file is read and one RDD is created with the name called RDD. After this, I am doing a transformation on this RDD called filter transformation, where I am going to name this RDD as filtered. Here, this RDD is going to be filtering out the data based on some of the business logic. So I am creating one next RDD over here as the transformation one. Next, I'm going to perform an action that is called count. I'm going to perform an action on this RDD as in count. Once the action is there, then only it will start executing from starting. But before this, it's like one lineage is going to be created. You can see that it keeps track of whole of the transformations that we have performed in the past. A lineage keeps track of what all transformation has to be applied on that RDD, including from where it has to read the data. As you can see, I have created this RDD named as RDD, second RDD named as filtered, and then we are performing a count operation or action operation. So it's like before executing anything, a lineage is created. Like once the action is done, execution will be performed from left to right or maybe from starting till end. But before that, a lineage, a backtracking thing will be done with the help of driver, where it is going to be stored either in memory or it's in disk. Why it is done? Because we need to get a fault tolerant mechanism. So let's say if something happens with this filtered RDD, this RDD, so how we can keep tracking? It's like first we'll see in action what we are going to use, which RDD we are going to use. It's like filtered RDD. Since we went there and we found that it's destroyed, so what we'll do, we will find out what's the parent of this RDD. So we'll go to this RDD and we can again create a filtered RDD with this RDD. Alright. It's like as you can see here in this, RDD is reading a file called spam.txt. Now I'm filtering out the data from that spam.txt only with the help of some of the business logic, and then I'm going to perform one of the action. Okay. So for this operation, before execution, lineage is going to be created in order to get us a fault tolerant mechanism in Spark. So how this lineage is going to be stored or how it is going to be performed? Lineage is stored in driver program so that if something happens or any child fails for some of the reasons, it will go and check the lineage and it will identify the parent of it and it gets executed sequentially. As I have discussed that, let's say if this is failed and we need to recreate it again, so we will track its parent RDD and from that RDD only we will create it back. We will create this filtered RDD back so that the order of execution will be as per previous order only. Alright, with the help of lineage, fault tolerance is achieved in RDD. So this lineage is a very vast concept in Spark in order to get fault tolerant mechanism, and which is a thumb rule. Next important concept we'd like to go for is lazy evaluation. Lazy evaluation is a key concept in Spark. Unless and until action is not called, transformation will not be evaluated. As I am discussing before also, once the action is called, then only whole of the transformation will be executed, whole of the codes will be executed in Spark and we'll get the value. As you can see here in the picture, Like, it knows what to do and how to do, but it will not do until and unless this action is called. So it's like, as we have seen in the example, that once count or maybe one show or any kind of action is called, that code is not going to be executed, right? So this also helps us for some of the fault tolerant mechanism. How it helps? Let me show you an example. Let's say we are going to create a RDD called file, where we are going to read a text file from my local system. Alright. So let's say my file is in home and Swati directory, and the file name is, let's say, x.txt. Alright. Once I read the data and I create a RDD, now I want to read first few lines of this RDD. Let's say I want to read first 5 lines of RDD. Alright, whatever there is in file, this x.txt. So what happens? First I'll create this RDD called file, and it will give me the result. Once I perform this take operation, it will give me first 5 lines of this RDD, what is there in x.txt. Alright. Now let's say what I'm doing, I'm creating another RDD called file1, and I'm doing the same operation, reading this text file only. But here, instead of text file x.txt, I'm going to write x1.txt, which actually doesn't exist. Okay, so whenever I execute this line in my CLI, it will be executed normally. It will not throw any kind of error. When it is going to be throwing any kind of error, once I call any action. Once I call this action as file1.take of 5, then it will throw us an error informing that this x1.txt doesn't exist. So this file1 RDD cannot be created. So here you can see how lazy evaluation works. It's like, if you are not calling any of the actions, it will not allow us to run any of the code. It will just grasp everything. It will just gulp everything, but it will not tell you anything. It will not perform anything. Here you can see the example that this x.txt existed. That's why this file RDD was created, and then we have got this value called file.take of 5. But as instead of this, if some other file name is there which actually doesn't exist, and I am not writing any of the actions operations here, and I'm just going to write transformation, it will just take whole of the data without throwing any error. Once action is called, then only it will throw error. Why? Because executions are performed while providing actions. As I'm repeatedly saying, that once actions come, then only executions are performed in Spark. I hope you guys are clear with lazy evaluation. So what actually lazy evaluation is? Until and unless action is not called, transformation will not be executed or evaluated. Let's move for partitions now. Actually what happens, Spark breaks up the data into chunks called partitions. So why it is done? Because this is to allow every executor to perform work in parallel. So what actually executor is nothing but it's the resources, it's the container available in our worker node. I'll just explain in Sparc Architecture, so bear with me for some time. This allows every executor to perform work in parallel. What happens? Let's say we have different partitions. Alright, and this partition is going to be in executor 2, this partition is going to be in executor 1, and this partition is going to be executed in executor 3. So whole of this partition data will be executed in our executors parallelly. Alright, what actually happens? A partition is a collection of rows that set on one physical machine in the cluster. If you have one partition, Spark will have a parallelism of only one, even if you have thousands of executors. Let's say you are doing just one partition, okay, and you have so many of the executors, but you only need to run this data only. If you have hundreds of executors and you have only one partition, so this partition will run only in one executor, right? So there we cannot achieve any kind of parallelism, right? And on the other hand, if you have many partitions, let's say you have 3 partitions but only one executor, so what happens that time? Spark will still have a parallelism of only one. See, you have 3 partitions but only one executor. in order to run all these code. So all these partitions needs to be taken care by only one executor, right? So here also only one computation will be achieved. No like parallelism will be achieved. Why? Because we'll be having only one executor. I hope you guys are clear with the partitions. What actually partition is? It is nothing but it's a chunk of data partitioned along in order to get high performance, in order to get parallelism, so that we'll be getting data instantly. Next, we'll proceed with Sparc APIs. What actually I meant with Sparc APIs, as I have discussed earlier also, that Sparc has basically two kind of APIs. One is low level API, one is high level API. So the two fundamental sets of API is low level APIs and high level APIs, where low level APIs are also called unstructured APIs and high level APIs are also called structured APIs. So under low level APIs, this RDD comes, that I have already discussed, that it's a building block, it's a fundamental unit of Sparc, right, which is immutable, which is lazily evaluated, which is dependent on parent, and we have discussed many other features of this RDD. Now, the high level APIs are also called structured APIs. So, what actually structured APIs are? This data frame and data sets comes under structured APIs, that is nothing called high level APIs. So, let me explain one by one, as I have already explained this RDD. So, now we will go for data frame and data set. So, what actually data frame is? A data frame is a structured API and it represents a table of data with row and column. It will be like normal Excel sheet you can consider. It's like in Excel sheet we have columns, we have rows, and it will be seen as tables. So the same way data frame would look like. Let's say you have a CSV file and you want to create a data frame on that. So it's like you can just create a data frame and it will just look like your Excel sheet. We can apply all kind of transformations and actions in data frames as well. We have seen some of the RDD's transformations and actions, like transformations means map, flat map, union, join, intersection, reduce by key, group by key, filter, any kind of operations that we use to perform for RDD. The same thing we can do for data frame as well. In our upcoming videos, we will see data frame in detail and we are going to discuss hands-on on data frame only, because in real time we used to create data frame in our project and we used to operate on that only. So you please don't worry about it. I'm going to explain in much detail on this Sparc data frame. Next we'll go for data set. Again, this is a high level API and structured API only. So what actually data sets are? Data sets are type safe version of Sparc structured API. So what do I mean by type safe? Type safe means we cannot accidentally view the object in a data set as being of another class than the class we put in initially. So this will prevent us from seeing another kind of object if we don't belong to that class, right? Due to this, data sets are attractive for writing large number of applications. In real-time projects, we used to create data sets as well and used to perform operations on it. So these are Sparc APIs. We have two kind of APIs, high-level APIs and low-level APIs, where high-level APIs consist of data frame and data sets, and low-level APIs RDD. I hope you guys are clear with Sparc APIs. Next, we'll proceed with Sparc Architecture. If you guys know actually what the component of this, what's the working functionality of this, you might be more clear while running any of the code on the cluster. Why? Because once you run the code, you will get to know how many number of executors you want, how many number of cores you want to put while submitting your application. In order to run any of the code, first you need to know the basic architecture of Sparc in detail, right? So here we are seeing in architecture of Sparc, there are few components like driver program, Sparc context, cluster manager, worker node, executor, task, and caching. So we will be going to explain it one by one. So let's start with this driver program. So what actually this driver program is? It is nothing but the heart of Sparc application, you can say. Actually, in order to run any of the application, we need our main function, right? So this driver program runs our main function and is responsible for mainly three things. The first is maintaining information about Spark application. Second one is responding to users' program or input. Third is analyzing, distributing and scheduling work across the executor. So it is responsible for mainly three things. Why? Because this is the only place from where user is going to get the output or user is going to put their input. So in order to get the output, this driver program must respond to user's program or input. And also for all the scheduling work, analyzing and distributing of all of the tasks across these executors, this driver program is responsible. Next, we'll look into Spark context. What actually Spark context is? It is nothing but it acts as a bridge between the cluster and the driver. Let's say these whole things are running in a cluster where cluster manager and worker node is under the cluster. So this Spark context, what it will do, it will act as a bridge between this driver program and that cluster. Okay, why? Because once we write Spark context or once we want to enter into Spark context, we just need to write Spark shell or we just need to initialize Spark con, and it will just know that I want my program to be run on the cluster. I want my program to be run on Spark cluster. So as I have discussed yesterday, like if we want to actually launch Spark context, so in normal CLI in REPL, we just need to write Spark -shell. Once we write Spark -shell, we will see that our cluster will know that I am going for the context of Spark only. I want to run my code under Spark cluster, right? And in the other hand, if we want to run our code in some of the other applications, let's say Maven or something, there we need to explicitly write Spark context as we need to initialize Spark const there. In hands-on, I will let you know how we are going to explicitly define Spark const over Maven application. Next, we will see cluster manager. So what actually cluster manager is? You can relate this cluster manager as Yarn's architecture resource manager. Yes, it means that it controls physical machine and allocates resources to Spark application. As we have seen in our Yarn architecture, that we have resource manager that is responsible for allocating resources across the cluster and also managing physical machines. This can be one of the three core cluster manager: Spark standalone cluster manager, Yarn or Mesos. We have discussed yesterday that we have three kind of cluster management thing in Spark: Yarn, Mesos and standalone applications, right? So this cluster manager, if we are using standalone cluster, so it will be the cluster manager for standalone cluster manager. If we are going to use Yarn architecture over Spark, so it will be our cluster manager for Yarn, and same goes for Mesos as well. This means that there can be multiple Spark applications running on a cluster at the same time. Alright, next we'll go for worker node. So what this worker node? This is a slave node and this is a master node, as we have seen in our Yarn as resource manager and worker node, right? So what this do? This worker node that runs application program in the cluster. How? See, once this driver program is submitting the code, this will go under worker node only, and here only all the codes will be executed. In order to run application program in cluster, this worker node is responsible. Next, we'll go for executors. What is this? Actually, executors are nothing but it's the resources, it's the container available in our cluster in order to run our jobs in the cluster. So it is responsible for carrying of the work that is assigned to it by cluster manager, because these are the resources where our program needs to be run. So each executors are responsible for mainly two things. First, executing the code assigned to it by driver. Why? Because these are the resources and this needs to execute its code. And the second thing is, once the code is executed, it needs to report the state of the computation on that executor back to driver node. The driver program first will submit its job to executor node, and once the task is completed, or let's say it's not completed, it's failed also, that needs to be submitted again, that needs to be known by this driver program with the help of executor. Next, we will look for this task. What is this? This is nothing but unit of work that will be sent to executors. Let's say we have created few jobs in our cluster and that needs to be run. So the unit of that work that will be sent to executor to perform the operation is nothing but task. So this is like that. And as we have already discussed what these caches are, let's say we don't want to save the lineage thing or maybe some of the broadcast variables in our disk and we want to use our memory, so we can use the same with the help of this cache. So now let me explain how this actually works, how these all components work together. First of all, as we have discussed this in this driver program only, here it is responsible for main function execution. While writing the program, we need to initialize the Sparc context in it so that this application, this cluster should know that I'm going to perform Sparc operations. So in the program only, I'm going to initialize Sparc context over there. Once the Sparc context is initialized, it will go and connect with cluster manager. Why? Because it is responsible for creating the bridge between driver program and whole of the cluster. Once the Sparc context is initialized, it will go and connect to cluster manager and it will say that I need to run my program and we need to get some of the resources. So this cluster manager is responsible for allocating resources and it will allocate resources to worker node whichever are available at the moment, and it will ask the Sparc context to launch the program in the corresponding worker node. So now this driver program is responsible to launch their program in worker node. Let's say this worker node 1 is available and worker node 2 is not available at that moment because of some other operation. So what this will do, this will just launch the job in this worker node. Now in this worker node already we have some of the containers, some of the resources provided by this cluster manager. Now it's the responsibility of worker node that all the operations would be performed without any kind of interruption. As it already has resources, so it needs to be executed. So under this only resources will be taken and the jobs will be started to run across this worker node. Once the jobs are finished, once the tasks are finished, now it's the responsibility of executor to show the output to driver program or to show the result, whether it is fail or maybe it is successful. It needs to show the output to driver program so that client would know what actually happens while running program in the cluster. So this way this Sparc architecture works, and this way like all the resources are used by driver program with the help of cluster manager. I hope you guys are clear how this Sparc architecture works. Also, I want to let you know like how Sparc program runs on cluster exactly. So there are three ways. First of all, we'll see what happens for coding thing. Second, what happens with lineage when we are performing these operations. And the third, we will see what happens while execution. So as you know that if we are doing coding, let's say it will read data from top to bottom, right? If we are looking into coding, so it will read the data from top to bottom, right? Next, if we are going for lineage, if we see what happens for lineage, so what happens is once the driver program launches its application in this executor, this executor is responsible for lineage thing. So it will store its lineage under the worker node if memories allow it to store it in it, or also it can store the lineage in driver program as well. So the lineage thing will be, let's say we have A, B, C kind of RDD. So it will be from bottom to up. How the lineage will be created from C to B, from B to A, this way. So lineage will be done from bottom to top approach. Now the third thing will be execution. So how will the execution be performed? Let's say with some of the lines of codes. So the execution will be performed from top to bottom approach. Why? Because let's say for top, let's say we have A. So in A, we are going to write that please read some of the file. So it will read some of the file. Now we are going to perform some other transformation. Let's say we are going to perform some of the map transformation. On what? We are going to perform map transformation on this A only. So for the execution, it needs top to bottom approach. So this way we are going to run our Sparc program on the cluster. I hope you guys are clear. Three ways are coding way, like how coding is going to be read. from top to bottom, how lineage is going to be performed from bottom to top approach, and how execution is done from top to bottom approach, right? Also, let me tell you, there is one more thing that is called deployment mode. What actually deployment mode is, you can see here this driver program. There are two kind of deployment mode. One is, let's say if you are using normal standalone cluster, okay, as I have already discussed, there are four kinds of cluster management things: standalone cluster management, yarn cluster management, then mesos, then local. So let's say if you are going to deal with standalone cluster mode, the driver program would be in client machine only. Let's say this is client machine. So driver program would be launched in client machine only, which is outside the cluster. This whole thing is cluster. Right, periphery is my cluster. So the driver program would be in client machine outside the cluster. But if we are going to run our Sparc program on the top of yarn architecture or Hadoop architecture, so this program needs to be in some or the other node inside the cluster only, and there only we need to launch driver program, and there only we need to launch our main function. So I hope you are clear with deployment mode. There are two kind of deployment mode: cluster mode and client mode. If we are using client mode, the driver program would be outside the cluster in client machine only. Okay, and if we are going to use cluster mode, this driver program would be launched in one of the node under cluster only. It needs to be under cluster, and this driver program or main function would be launched under the cluster only. I hope you guys are clear with today's session. Today we have discussed some of the important concepts and the main basic thing, Sparc architecture. Thank you for watching.